chemical equation will look something like this. If you haven't seen one before, let me just break it down really quick. So on the left-hand side, you'll see one or more chemical formulas, and we refer to these as the reactants. On the right-hand side, you'll see one or more chemical species, and we'll refer to these as the products. These will always be separated by an arrow, and this arrow shows that a reaction has taken place. So the reactants are what you start with, and they produce the products, which is what you end up with. Generally, these will have some parentheses with a couple letters in between them. In this case, they're all in the gaseous state, but the parentheses with a letter refers to what state the matter is in. If it's a G, it's in the gaseous state. If it is an L, kind of like a cursive L, then it's in the liquid state. If it's an S, it's in the solid state. And the only state of matter that we didn't discuss yet is an AQ, and this stands for aqueous. An aqueous state means that you have it dissolved in water. So if it's dissolved into water, making a homogeneous mixture of some sort, then you have an aqueous substance. Now the law of conservation of mass says that however much mass you have at the beginning of the reaction, so however much mass your reactants have, you will have the same amount of mass in your products. This isn't completely true. It's better to talk about the law of conservation of mass and energy because you can take matter and destroy it, turn it into energy. For now, though, we're going to stick with the law of conservation of mass because it's a really good starting point. What that means for chemistry, excluding nuclear chemistry, is that however many atoms of a particular type you have in the reactants, you need to have that same number of atoms of that type in the products. When we write out a chemical equation, we make sure we have the right number of atoms on both sides of our arrow, and we call that balancing the equation. The balancing of chemical equation is really important because this chemical equation is modeling for us what is happening. If it's not balanced, then it's not an accurate model. So I don't want you to feel like, oh, if I don't balance it right, something's going to explode. That's not true because what is happening is going to happen, but how you are understanding what is happening will change based on how you balance the equation. So I'm going to walk you through how to balance this as if you've never balanced a chemical equation before. As you do this again and again and again, and you will use this skill all the time in chemistry, it will start to feel more natural, and you may not have to take all of these steps, but I just want to start at the very beginning. So I would draw a line between the products and the reactants, and then I'm going to list all of the elements that are present. So we have carbon, we have hydrogen, and we have oxygen present on both sides of the reaction. If you have different elements present on either side of the reaction, then you have definitely written your reaction equation wrong. So you should have the same elements, and then the next task is to make sure that we have the same number. So on the reactant side, I only have one carbon, so that goes here. I have 4 hydrogens, and I have 2 oxygens. On the product side, I have 1 carbon, I have 2 hydrogens, and now I have 3 oxygens. Make sure to include them from both of the species that the oxygen is present in. Since the number of hydrogens is different on the reactants and products and the number of oxygens is different, we don't have a balanced reaction equation. Now I can't change the number of atoms of a particular species by changing the subscripts. Those are set. This reaction says it takes CH4 plus O2 and it makes carbon dioxide and water. It doesn't make carbon dioxide and hydrogen peroxide, it makes water. So I can't change that. The only thing I can change is what we call a coefficient. So there's a space in front that can say how many water molecules it produces. Once you've written the reaction or have the reaction given to you know what is present at the beginning, what chemical species are present at the end, you can only change how many of each molecule you get. Since our carbons are already balanced, let's look at our hydrogens. We have 4 hydrogens and 2 hydrogens. We can't make less hydrogen on the reactant side. The only thing we can do is add more to the product side. I have 2. But I want it to be 4. So if I multiply 2 times 2, that equals 4. So now I have 4 hydrogens, and that's really good. But by putting this coefficient here, that affects the number of hydrogen, and it affects the number of oxygen. So now I have 2 times 1 oxygen, and so I actually have 2 oxygen from the carbon dioxide, 2 oxygen from the water, so I have 4 oxygen here. So our carbons are balanced, our hydrogens are balanced, so we need to go balance the oxygen. Now I have 4 over here and 2 over here, so you always start on the side that has less, and you see if you can add a coefficient to make it the same. If this is 2, then I need 2 molecules of oxygen in order to make 4 oxygen atoms going into the reaction. So what this means is that I have 1 methane molecule reacting with 2 oxygen molecules to make 1 carbon dioxide, and 2 water molecules. All right, now it's your turn. I'm going to show you a new reaction. Pause the video and I want you to see if you can balance it, and then I'll walk you through right after. So if we draw a line between our reactants and products, and then we list which elements we have present, and then we list how many we have. So we have 1 sodium and 2 bromine, 1 sodium and 1 bromine. Since the sodium is already good, let's start with the bromine. I have 2 on the reactant side, and I have 1 on the product side. And we'll add a 2 here. So now we have 2 bromine. But this also changes the number of sodium that we have. So now we have 2 sodium. Since our sodium is no longer the same on both sides, we have to go back to the reactant side and add a 2 here in order to have the same number on both sides. All right, here's another one. I want you to pause the video and see if you can balance this one. So we only have phosphorus and oxygen present. We have 2 phosphorus and 5 oxygen on the product side. We have 4 phosphorus and 2 oxygen. If we start with the phosphorus, we need to add 2 here to give this 4. But that changes the number of oxygen that we have. We go to the reactant side, the phosphorus is still good, but our oxygen, we need 5 times as many, so we put a 5. Okay, I'm going to up the game a little, putting together all of your nomenclature with the balancing of equations. See if you can pause the video and write a balanced reaction equation for the reaction of sodium phosphate with iron 3 chloride to form iron 3 phosphate and sodium chloride. Did you get it to look like this before you balanced it? Let me tell you, a way you can always check your work is if you write out the equation and then you keep balancing in a circle and you just can't get it to balance, there's a good chance that one of your ionic formula is not balanced. So you need to make sure that you have the charges canceling. So iron 3 has a 3 plus charge, phosphate has a 3 minus charge, so you only need one of each. Sodium has a 1 plus charge and phosphate has a 3 minus charge, and that's why this 3 is here. So if you can't get your reaction to balance, probably there's something wrong with your formula. And let me show you an easier way to balance this. Now, if what you're doing works for you, that's great. This is just a suggestion. So when we're writing out which elements we have present, if there's a polyatomic ion on both sides of the equation that's completely unchanged, then you can just balance with the polyatomic as if it were an element itself. Now, if the polyatomic is changing and turning into the reaction, you can't do that. But if it's present on both sides, then this makes it a little bit easier, especially if you have a lot of polyatomics. Tracking the oxygen gets really tricky. If we did it this way, we have 3 sodium over here. We have just 1 phosphate. We have 1 iron 3 and 3 chlorides. Over here, we have 1 sodium, 1 phosphate, 1 iron, and 1 chloride. So let's start with the sodium. We have 3 on the reactant side, 1 on the product side, so we'll put a 3 here. Now that changes this, and it also changes the chloride. If you look at your products and your reactants, you see it's already balanced, so we just needed to change that 1. Okay, and then one last one. We're going to write a balanced reaction equation for the reaction of ethanol. I've given you the formula here, C2H5OH, with oxygen to form carbon dioxide and water. So pause the video, see if you can do this. All right, so when writing this, the number 1 mistake is forgetting that oxygen is diatomic. So don't forget there are 7 atoms that are always going to be present when they're just by themselves in a group of 2. Notice we just have 1 water here. It doesn't mean that oxygen is always a pair. It just means when oxygen is by itself, meaning there's nothing else in the compound. It's a group of 2. Okay, so to balance this, we'll draw our line. We've got carbon, we've got hydrogen, and we've got oxygen. On the reactant side, we have 2 carbons. We have 6 hydrogens, because we have 5 here and 1 here. And we have 3 oxygens. On the product side, we have 1 carbon, 2 hydrogens, and 3 oxygens. Now, if you have something that's present in more than one species, like if you look at this, oxygen is all over the place. It's in everything. I recommend leaving that for last. If you balance everything else, ideally at the end, that one will already balance itself out. So let's leave oxygen to the very end because we can't adjust the oxygen without changing something else. So let's start with the carbon. We have 2 on the reactant side, 1 on the product, so then we can put a 2 here. Now that changes the number of oxygen. We have 2 times 2 plus 1 is 5 oxygen. Now, next, let's do the hydrogen. So we have 6 hydrogen on the reactant side, 2 hydrogen on the product side. So we need this to be 6, so we can multiply it by 3. 3 times 2 is 6, but that changes the number of oxygen. Now we have 2 times 2 for 4 oxygen here, 3 times 1 for 3 oxygen here. We have 7 oxygen. We have 1 oxygen here and 2 oxygens here. So I think it's helpful to say, okay, I have 1 here and I have 2 here. We're not going to bother that 1 because that would change the amount of carbon and hydrogen. So we need to change this to be 6, and we can change that to be 6 by adding a 3 here. The last thing I would do is go through and double check. We've changed a lot of things and it's easy to just make a little error. I think it's balanced and it's not. So if we go back and just double check, we have 2 carbon, we have 5 plus 1, so 6 hydrogen, and we have 1 plus 6, so 7 oxygen. We have 2 carbon, we have 6 hydrogen, and we have 4 plus 3, so 7 oxygen. After double checking, we can confirm that this reaction does in fact